function foundations review. Okay. We've got number 1 is asking us to state domain and range of the relation. So a lot of this vocabulary you need to go back if you're still unsure of. You need to go back and be studying your notes or reviewing your notes, especially that supplemental note page we did last Friday that went over all the key features just in general and not just about the parent functions. Because we need to remember that domain is our x's and range is our y's, or f of x's. Okay, so range is vertical, domain is horizontal. And in this case, they do use f of x. That's the same thing as y. So we're looking here for our domain and under f of x for our range. So state the domain and range. This is not a function. It is just a list of ordered pairs. Now, I'm not saying it's not a function. I haven't checked that it's a function. I'm saying it's not an equation. Okay, so it's not a line or a curve or anything like that. It's just a scatter plot of these 5 ordered pairs. So when I list the domain, I am literally just going to list the values. Okay, and we use that little squiggly bracket. This is called the set notation, and I'm just going to list all of the values in the domain. So I am just listing all of the x values, and I do this from least to greatest. So -2, -1, 0, 3, 5. So that is my domain. It's a list of all of the values, all of the x values that are in this relation. And the range, same thing, but all of the f of x or y values. So that would be -3, -2, -1, 0, and 3. And that's it. That's the domain and range of that relation. In number 2, they ask for domain and range, but this time they give you a graph. So this one is a visual, not just a list of values. And this is not just a scatter plot. These points are all connected. It's a continuous interval here. So I like to mark on my x-axis, my horizontal axis, the furthest left my graph goes is right here. This is the x value. And the furthest right that my graph goes is right here on the x-axis. So that is from -1 to +5. And remember, with interval notation, you just go least, comma, greatest, and then we have to either choose bracket or parenthesis around those. When it is an open circle, like where x is -1 here, that means that that value is not included. So we use a parenthesis for not included. Okay, at 5, that is a solid, as long as it's not an open circle. If you see a solid point, okay, or it's just a line going through that point, or stopping there, it's included, unless you see that open circle or like an asymptote. So the 5 is included, so we use a bracket. That is interval notation. If you prefer inequality, that would be written as -1 is less than x is less than or equal to 5. See how we did the or equal on the 5? That may help you remember that the bracket is the or equal that's included because it has that little horizontal line just like the or equal. Okay, the -1 was not included. Okay, so both of those notations would work. Now for the range, I look at my y column or axis or f of x axis, and I'm going to do the same thing. I'm going to mark how low does my graph go. So this is the lowest y value here, and the highest my graph goes is up here. So that goes from -6 to +6. And again, it's least to greatest. So for range, that's bottom to top. And the -6 at the bottom, that's where the open circle is. So that's not included with a parenthesis. And then the 6 at the top is included. So it's a bracket. So for inequality notation, it would again look like this, not including the -6, and we would use y, or f of x, and then we would include the +6. So either of those notations is correct. You really need to familiarize yourself with interval. I know you're used to using inequality because that's what you initially learned, but interval is going to be what you're moving toward and using most often now. Number 3 gives you a big table to asks you to fill in and be able to identify commonalities amongst these functions. Okay, so we have to know our parent functions. Okay, so absolute value. Now, I think I told you this in class, but I'll remind you now if you're watching this video. You do not have to have the equation memorized. If it asks something about the absolute value function, it's going to have the equation written out for you like this. I don't want you or expect you to just have everything memorized. That's not beneficial. You need to understand what these different key features are and how to find them for any graph, not just have them memorized for the parent functions. So I know I showed y'all in class, but I would use Desmos like this and have when I get my test, I'd open up my calculator and I'd type in all my different parent functions. Okay, so one of your problems is going to have them all listed as choices. So you'll be able to find all of these throughout the test somewhere. So you can list them all out, and then remember this circle to the left turns them on and off. So absolute value, I can just come over here and turn it on and see it. Okay, so here is my absolute value function. It's the V shape. So I want to know all those details about it. Okay, so I'm looking at this graph, and this graph goes forever and ever, left and right. If I went up, that would keep going forever, ever, 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 ever. It's never going to stop. Okay, and you can hit this little home button over here to go back to center. So you're not going to see arrows in Desmos telling you that it keeps going. You need to understand that it does keep going. So now there is a low point here. It does not get lower than the origin. So our range is limited. Okay, it goes from 0 up to positive infinity, but our domain, it goes left forever and right forever. So that's all real numbers. So for domain, it says interval and inequality notation. So I'm going to do both. So negative infinity to positive infinity, and you never include infinity because you can't equal it. Okay, inequality notation would look like this. Now, I'm also going to add this little symbol so you remember that all real numbers. Okay, now the range for this one, I said was limited. It went from 0 up to positive infinity, but the 0 is a point on the function, so that's included. So when we write this, we would include the 0, but not the positive infinity. Okay, now intercepts. That function, you can go back to it and look. Well, maybe I can go back to it. Man, I've got a lot of stuff open. You can click here and see where that intercept is. It's at 0, 0. That's where it's on the y and the x-axis. Remember, if your graph crosses through the origin, that is both an x and a y intercept. So x and y intercepts are 0, 0. Okay. Symmetry. We talked about symmetry. We said that we practiced talking about if your graph is symmetric about the y-axis. That means that the y-axis serves as an AOS, or an axis of symmetry, and every point on the left and right would mirror each other. It's a reflection over that line. Okay, that's what the absolute value function is. If I folded it along the y-axis, it's symmetric. Okay, so this one is get a different color for this. Symmetric about or across the y-axis. Or you could say y-axis symmetry or something like that. Okay, if you want to make sure you understand that that means that your AOS, your axis of symmetry, is the vertical line on the y-axis. Remember, go back to that. If you have a line here that is crossing the x-axis, so a vertical line is x equals 0. And you could add that over here. Let's graph that. Why won't you move? Okay, so I could say x equals 0, and that purple line popped up, and you can see that is my axis of symmetry, my AOS, that this is reflected across. So your AOS is x equals 0. If you're not sure if it's x equals 0 or y equals 0, or you get confused, go to Desmos, check it out. Okay, this function did not have any asymptotes. Remember, asymptotes were lines that the graph approaches but never reaches, never touches. Okay, so there are no asymptotes for absolute value. Now, a minimum or a maximum, this graph does have one of those because it has a turning point here at the origin. Let me turn that off. At the origin here, the graph changes. And when I say changes, I'm talking about changes behavior or direction that it's going. If I were to trace this from left to right, because I go left to right like I read a book, I'm decreasing, decreasing, decreasing. I get here, and now I'm increasing, increasing, increasing. So when you have a turning point, that is called a vertex. And that vertex is going to be a maximum or a minimum. Okay, so that's a high or a low. This is a low point on the graph. So I do have a minimum at 0, 0, and it is a vertex. Now you can have, just gonna add that there. You can have a maximum or a minimum on a function if it's like an endpoint, for instance, that's not actually a vertex. It's not a turning point, but it's still like a low point on the graph or the highest point on the graph. This one happens to be both. It is the vertex and it is the minimum. It is actually the absolute minimum because it is absolutely the lowest point on that graph. If you have any questions about domain, range, intercepts, symmetry, asymptotes, max, mins, vertices, all of this was in that notes supplement after we did the key features of parent functions packet notes. We spent like 4 days on that notes packet, and then at the end of the week, after doing some practice and taking a FA, we went back and did more supplemental notes on it to reiterate. So go back and look at your notes. That's where all of this is coming from. Okay, now the square, I'm going to start going a little faster through these now that I've kind of already talked about what those key features are. So for the square root function, that's the f of x is the square root of x. So I'm going to go back, I'm going to turn absolute value off and square root on. Okay, so here's the square root function. It keeps going forever to the right, but it's got an endpoint here at 0, 0. That's where it stops. Okay, so when I talk about my domain, left to right goes from 0 to infinity. And I talk about range from bottom to top. Again, it goes from 0 up to infinity. So domain and range here are both 0 to infinity, including the 0. So there it is in both notations. Interval and inequality. All right, now intercepts and symmetry. So this one has a point at 0, 0. So that's both the x and the y-intercept. And it doesn't cross the x or y axis anywhere else. So it is only the origin and it is the x and the y-intercept. Okay, that graph did not have any symmetry. Okay, it was not symmetric about the y-axis. Like if I folded it over the y-axis, there's nothing over here that would match up with. Okay, it's also not the other type of symmetry that we talked about, which was symmetric about the origin. That's the one where you rotate it 180 degrees. So you rotate it upside down and it appears unchanged. Okay, that would not be the case here either. So this one has no symmetry. And then asymptotes, this one also had no asymptotes. And then this is one that does have a maximum or minimum. This is the lowest point on the graph. It is the absolute lowest value. So 0, 0 is an absolute minimum again. But this time, it is not a vertex because it's not a turning point. It's just an end point of the graph. It doesn't change direction there. So for absolute value, that was a vertex. For this one, it is not a vertex. So you don't have to write that, or you can add a note to yourself and put not a vertex if you need that reminder. All right, now the cubic function is f of x or y equals x cubed. So let's check that one out. I'm going to turn square root off and turn cube on. So hit home, go back to center. This one goes down and to the left forever and up and to the right forever. Okay, and there's no gaps or breaks or anything like that. So left to right forever, down to up forever. So this one has all real numbers for both the domain and the range. So again, you can write the number symbol, all real numbers. You can do, oops, I started to write a bracket. It's a parenthesis, negative to positive infinity, not including them. So like, I don't know why I just wrote a 0, y'all. It's getting late. I'm getting tired. All right. And then same thing for the range. All real number symbol, negative to positive infinity, or an inequality notation like this. Okay, and then x or y intercepts. This is the cubic function also goes through the origin. So it also has an x and y intercept of 0, 0. This one does have symmetry. If you look back at it, it is not symmetric about the y-axis. It's not the one that I could just fold over and everything matches up. But this is the one I could rotate 180 degrees and it would appear unchanged. So you can turn your computer screen or phone, whatever you're looking at this on, upside down, and that looks exactly the same. Or if you have this on paper, turn your paper upside down and it looks exactly the same. It appears unchanged when you rotate it about the origin. It's like you put your pencil here at the origin and rotate your paper 180 degrees, it's still going to look exactly the same. So that's what symmetric about the origin meant. And you can go back and watch the video of those notes if you've forgotten that. Okay. But this one is symmetric. Across or about the origin, or you just may hear origin symmetry, something like that. Okay, no asymptotes. This one doesn't have any. And this one, the range is low to high forever. This range is all real numbers. So that means there is no absolute maximum or minimum because it keeps going forever. And there were no turning points in that graph. So there's no vertex to create a relative max or min. Okay, so this point, okay, the concavity of the curve changes there, yes, but the behavior doesn't. I'm increasing, 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 still increasing, increasing, increasing. Okay, so that is not a vertex. We talked about it. It is called a point of inflection, but there is no max or min. But I'll just put a little side note here. There is a point of inflection at the origin. Okay. All right, then cube root. F of x equals the third root of x, or the cube root of x. I'm going to go back to our graph, our Desmos. I'm going to turn off cubic and turn on cube root. And actually, I'm going to go back here and I'm going to delete, 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 because I want to show you how to type that in. I've showed you before, but I want to remind you, it is not on this main keyboard screen. You have to hit functions and scroll all the way down to the bottom. And it's this nth root, and you get to type in what that index is. In this case, it's a 3, and then under there would just be x. Okay, so that's how you would type in the cube root of x. Now this looks very similar to the cubic curve, but kind of turned on its side and flipped over or something. Okay, so here we still have that point of inflection at the origin. It still goes left and down forever, right and up forever, just at different rates. Okay, so domain and range are still all reals, intercept still the same, point of inflection still the same. Symmetry is still the same. If I rotated this, if I held it down here at the origin and rotated it 180, it would look exactly the same. Okay, so everything in the cube root function is actually the same as the cubic function. So all real numbers, negative to positive infinity. For both your domain and your range, because that's left to right and low to high. We said it crosses at the origin, so that's your x and y intercept. And we said that it was still symmetric about the origin. So same. Save myself some writing. And there are no asymptotes. And it also had the same, no max or min, but it had a point of inflection. So I'm again just going to write same. I guess I could have just written same for all of it, but that's all right. All right, so we've got 3 left here. Okay, so exponential. I'm going to go back to Desmos and turn off the cube root function. Turn on the exponential. Now, when you're looking at the exponential in Desmos, if you type in b to the power of x, it's not going to graph anything because you haven't selected a b value, a base value. So we use 2 just to get an idea to see the parent function. We did that in our notes as well. So we're going to type in 2 to the power of x. So I can see I cross the y-axis here at 0, 1. And this is the one that is approaching the x-axis on the left, and it looks like it just levels out at it, but it never reaches. Okay, this is indicative of an asymptote here. Okay, you don't see the asymptote. Desmos doesn't graph the asymptote for you. Okay, you have to be able to visualize that. So this is our first one that has an asymptote. Okay, and that asymptote is a horizontal line that crosses the y-axis. So it's y equals, and it's at 0. So y equals 0 as an asymptote, 0, 1 as a y-intercept. And if it never crosses this asymptote that essentially is the x-axis, that means there is no x-intercept. Okay, this graph goes left forever. It goes up and to the right forever. So left to right, our domain is all real numbers, but our range never gets below that asymptote. So our range is actually limited. Domain, all reals, And the range is going from 0 up to infinity. Now this time, the 0 is not included because it's an asymptote. So make sure you use a parenthesis there if you're doing interval notation, or if you're doing inequality notation, make sure your inequality does not have an or equal symbol on it. Okay, and then we said it crosses, there is no x-intercept because it never crosses the x-axis. And we said there is a y-intercept at 0, 1. Okay, as for the symmetry, actually, I don't think we talked about the symmetry. Let me go back and show that one to you. This one does not reflect over the y-axis, and if I rotate this 180 degrees, it definitely looks different. So this doesn't have symmetry about the y-axis or the origin. Okay, so no symmetry, but let's see what was next. No symmetry, none there. Oh, asymptotes were next. So this was the first one that actually does have an asymptote, and it has a horizontal asymptote.